and a very detail-oriented picture at the same time. And most of you want to work at one level or the other. Either you're sort of thinking big thoughts, philosophy and love and, you know, world peace and stuff, or you want to be adding two numbers together. And again, in computer science, we're still doing all those at the same time. So it's important as you're writing your code to understand that the big project has some sort of structure to it. These parts interact with each other, but at the same time, you have to keep in mind what the words array is, what the word count array is, what the word score array is, what the number of the words so far number is, what your loop you're trying to write is, these very detailed kind of things, right? And it's sort of actually hard to think about the back and forth of those two issues. So there are pieces in that code that I put there to help you in some sense. So someone tell me, what does index of word in array? That's one of the methods you should be writing, so it should be familiar too. What does it tell you?
The index of a word in array.
It tells you if there's a word in the words array, it tells you the index. That's half of the story.
And then returns that index.
And it gives you the index. It's still the same half of the story.
And if it's not in that array, it returns
-1.
-1.
So if it's not in the array, it turns -1. So a lot of you wrote that and then just flush it out of your brains. You didn't care about it anymore. What else does index of word in array tell you at a higher level than it gives you the index of the word or it gives you -1?
Yeah, you can use it to find the word's cumulative score and its overall total appearance, so you can figure out what its average score is.
Okay, so that's using it a lot. I think you're in the right direction, but you sort of jump to the next step as well. But more generally, what does this method tell you?
You can use it and just simply, is the word there? If it's not, then I know where it is or if I need to add it.
So index of word has two possibilities. It either gives you the index or it gives you a -1. And as you're saying, instead of thinking about all these possible cases, it's going to give you a 10 or 20 or 100,000 or 5 or -1. This tells you word in array, and this tells you word not in array. Right? You can use this to decide whether a word's in an array or not, this method. Where else does that show up in the code? This problem here. Trying to decide whether a word is in an array or not.
Index the best word?
Index the best word? Yeah, but I think that one you're going to actually have to solve, because if you use this to get the index of best word, you're going to grab the word and not know whether it meets the score criteria. So there's another spot that...
When you want to add to the word count?
So that process words method asks the question, if the word is in the array, add to the score and the count for it. If it's not in the array, then add it to the end of the array as a new word, right? There's two possibilities in that method. And I am seeing just loop after loop after loop inside loop for people's process words. Like they got 6 loops inside each other, all trying to figure out what token they're on and whether the word's in the array. And let me tell you why that happens. That happens because, sadly, we are not that smart. So we hit a certain level of complexity in our thinking and our brains just blow up. And we can't handle it anymore. And when you can't handle it anymore, what happens is you write code that is just the wildest mess you can imagine, because you've just lost track of what's going on. So as computer scientists, how do we tackle this issue? We tackle this issue with abstraction. And so rather than trying to solve in a method, process words, am I finding this word in the token, is this token in the word list or not? Plus I want to do this stuff to the arrays at the same time. I use something else that tells me whether that word is in the array list. And if it is, I do something very simple. And if it's not, I do something very simple. And I flush half the complexity out of the way so my brain doesn't blow up. Okay? And it's important to have that skill where if you are getting into something where you're tracking like 3 things at the same time and looping around things and trying to decide stuff, it probably means you need to take a little deep breath, and think about your solution a little bit and see if there's some things that can help you get to where you need to be. Now, I'm not, this is not a surprise to me. It is hard to identify the pieces that can be abstracted away. It's hard to identify other code that you barely understand as a way to help you solve that problem. Those are skills you pick up through practice, but it is something you need to just keep in mind. That we're not trying to get you to write code that has this like enormous complexity. Somehow, if you're headed down that path, there's probably something else that you're, need to think about a little bit that can help you. So, and the sad thing is, of course, I don't know. If I were to show you my code and I think I'm planning to in the lab actually do some sort of code review thing. If I show you my code for process words, it'd be like, oh, that's so easy, like you would, you'd kind of freak out because you spent 5 hours working on that thing, right? And the goal is to start recognizing how easy it is yourself, okay? Okay, so be wary of too much complexity in your code. It means you're doing something a little off. If you understand the structure of all the code a little better, you'll see there are pieces there to help you. The unit tests are there to help you. I had people email me, and they're kind of like, someone in my class has something that has a green bar on it. How do I get a green bar? So anyway, there's that other file, a test file. And if you open it up and click run there, it will run those unit tests for you. And it's a way of helping you focus on one method at a time. Because again, some of you are kind of overwhelmed by the big picture, and you don't know how to, so there's basically the entire program, and the entire program is made up of all these little boxes that interact in different ways. The flow of execution goes here, and then moves up here, splits off, and goes here. And so you sort of only see the big thing, and there's a big mess of activity inside it, and it's hard to focus in on, I need this thing to work correctly, right? I need this one piece here to be correct. And all you see is that the whole program doesn't work correctly, and you don't know how to dive in and kind of figure out how to attack that problem. So if you run some unit tests, it will say, oh, I believe this piece is good, has the check mark, this one, and this one good. And if that's the case, think about going and looking at this method and getting that one working according to the unit tests. Now again, the unit tests aren't the full answer. It doesn't solve everything for you, but at least is a way to attack this complexity issue and think about where you should be focusing your attention. So run on. And again, always stick with, try the debugger. Again, it's a tool. Tools take time to learn how to use well, right? We don't spend a lot of time showing you that stuff because everything gets real tiny on the screen and stuff like that. It's sort of a pain, to be honest. I don't ask for the debugger from you a lot because it's hard for me. You're going to send me a movie of watching you debug something, like, kill me now kind of thing, right? So I often ask for print lines from you as output, as a way to see what's going on, but you yourself should be practicing the skill of the debugger and seeing what it can do for you. For example, I have a lot of people asking me about infinite loops, like in the lines, string to, I can't remember, the last function, the lines, whatever thing, process lines, and you get infinite loops in there. And my belief is that if you were to run it in debug mode, so start running the debugger, and you hit the little red box to stop it, it will stop in that little infinite loop somewhere and tell you what line it stopped at. So if there's only like 3 lines in an infinite loop doing something, it'll tell you kind of vaguely just where it is, where it stopped, right? Or then you hit breakpoints, run to the breakpoint, step, 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 and you realize, oh, I'm in this loop a long time here, right? So I should be nervous. So those are skills on the debugger a little bit. Now, I am leaving on a trip right after class. I'm worried about all the emails I've been answering the last 2 days are suddenly going to be mostly cut off. Some of the TAs may be able to have some time, but a lot of them already used up all their staying extra for help hours, like in the CADE lab I know the last couple days. So better ask me some questions now. Questions on the assignment? So are you?
Yeah. Could you help explain how to import the file? I've been having a problem getting the file to show up that says the files.
How to read the file, not how to read the text file?
Yeah, how to get the program to like import it and then read it.
So import, in Java means something else, right? Imports we use for other packages and stuff like that.
Yeah.
So
Or to read it.
to read the file, right? So what's the question here? I mean, you want a review of file reading, or?
That'd be nice. Basically.
Oh, okay. I won't spend a ton of time on it because there's some information here. So basically, first of all, let's think about our project folder. And in that folder, we have like a source folder and some other stuff. And there should be a movie reviews, I'll just say movie.txt in that folder, right? That's what should have come down from the zip file or CPM. Now, there are a fair number of people I'm seeing, and I can't understand what's going on exactly, but they're like moving this inside like a lib folder, or moving this file down inside source A5, all over the place. And I know it's because it's not working for you, and so you're just trying whatever you can figure out. But fundamentally, stick to the plan. Don't go. It's gonna make, solve your problem rather than make new problems. So what are the steps we need to open a file? What do we need first of all? What's the starting data we need to open a file?
No, you need to create like a file object.
So that's the second step. What's the first step we need? File name. Okay, so we need a file name. And what type is that?
String.
So it's string. And the file name is this thing here, right? And again, it can include a path if we have this in some other location, but if it's set up properly inside the project folder, if you open up your project folder in Windows Explorer or Finder in Mac, you would say, open that folder and you would see this inside there, right? It's not buried down inside it. What's the next thing? Somebody just mentioned it. We need a file. That's a new file from that file name. So we turn the string into this file thing that we don't really know what it is, but Java uses it to kind of track what file we're working with. And then what do? Scanner, make a scanner from it. So we have a scanner, new scanner from this file. And then what do? We just do the same thing we do with all scanners, right? We ask if there's a token available, and then we grab the token. And in this case, the token we're grabbing is a line. Next line has next line, not a single word, right? We're grabbing a whole line at a time and sticking it in there. Now, there's a little bit of complications, right? There's some try stuff. We put a try and a catch around here, but just follow the pattern of that. Yeah.
I spent forever getting to that try-catch point. Like I could understand from the lecture notes why it has to have that try-catch or it doesn't work.
So that doesn't work. Okay, the question is, why does it have to have this try-catch? We've had other things that can cause problems, and we don't have to have a try-catch around there, right?
Well, see, because when I was doing it, without changing anything else except adding that try-catch, it would not find the file until it had that try-catch around the scanner.
I don't think it should even let you compile the code unless it has a try-catch.
Fair enough.
So I'd be surprised. Anyway, I'm a little surprised that there's something else going on there. So Java makes a distinction between exception things that have to be handled and ones that don't have to be handled. And it seems funny in a way, but there's a decision saying that trying to open a file that doesn't exist is common enough in some sense that we better make sure our code has some mechanism to deal with that. And the mechanism is you put a try catch around this thing. And it'll sort of do it for you, right? You hover over it and it says, I want to be fixed. There's two options to fixing this. And it will wrap this in a try catch for you. This is one of those things that, again, there are a lot of subtleties to what's going on, and I'm more expecting you to kind of follow patterns and just sort of do what you're told in this case. But it gets a little complicated, I know. But that's basically it. And if you're not getting this file, I don't know, and this is here for sure, there's got to be something in your code that is a little bit off from this pattern or something like that. So be careful with that. Yeah.
How concerned are you with the return statement for the catch?
I'm concerned with the return statement for the catch. So
select the exception.
So if it catches something here where the file's not found, in this particular method, I believe I specify what should happen. What should happen if the file's not found? It returns null, right? So in the catch, just return null. Right? I'm not that concerned about it because it seems pretty easy to me, right? Just return that. And if you get past that, then you return the thing that we need, the arrays that are filled with the values. All right, another question?
Will we be graded on our use of abstraction, like the index of word in array?
So do you have to use that index word array? No.
Probably best.
Are you more likely to make mistakes if you don't use it? I believe so, because that's what I've seen a lot of mistakes, that people aren't using it. It's not that hard. I mean, it's basically the same code as the word in array in some sense, so it's not that hard to get it right. So I won't be looking for that at this time. But I just would, it's good practice. Start getting in the habit of trying to boil down complicated code into simple method calls.
Just on that note, I feel like, I didn't see it until I was all the way done. Maybe.
Sounds like you're working.
Well, like I went through the main.
Yeah.
And then I went back and like, oh, what's this method? And then after.
Yeah.
I don't know.
No, I know. I understand. It's not, it wasn't prominent in people's minds necessarily. I understand the reason that people were not catching that connection there, not seeing that. So it's not a big deal. Do you have a question?
Yeah. So how does, there's like a file that has the next thing for a scanner, right?
So most scanners, you check for a token and then get the token.
Yeah. So is there like a similar thing for arrays so that we know when the array is we're looking at?
No. So one difference between a scanner and an array is that an array allows sort of random access into the array, not in order. So there's no sense of it being like a last item because maybe I want to go from the big end to the beginning or only pick out the middle 5 or something like that, right? So there's no real mechanism. Of course, there is an array length that tells you how many spaces are allocated in the array. Is that how you're looking for? But it's not saying. And then in our project here, I have, so let's say we have an array, and it's a fixed size, and we've added in a boy. We found 2 words to put in that words array. And the question is, let's say we have a new word we want to put in. Where does it go, right? There's 16,000 spots here. We've only used 2 of them. That's what that number, that painfully long words so far variable is supposed to be telling you. So if this is in index 0 and this is in index 1, there's 2 words that are used. This has a value of 2, and it tells you index 2 is the next spot to put the next word we're trying to add to this long array, right? So put it into, we put in the, and then this becomes 3 because there are 3 words used so far. And the next spot is actually going to be 3. This is the one tricky concept, I think, in this whole project, right? That you have an array of length. This will always be the length 16,444, if I remember the number correctly, right? That's the size of it. But we're only using a portion of that array at any actual 0. And in this case, it stores a 0. When you say, what value do you have? It says here, oh, I'm not referencing anything. 0 is a special case. It knows that an object is not stored at the memory location 0. And it just says, there's no object here for me to use. Now, why would this show up? In all likelihood, when you make your words array, well, I made it for you, really. It is initialized to some default value. What is the default value of an object array? Null, right? So each one of these is null. All right, I'll finish the job. I was about to give up, but those are all null. This is the words array. At this time, if I said words 1 length or something, like how long is the string stored there, it would say, okay, in words array, go to index 1, get the object that's referenced by that reference, it's null, try to apply a length method to a null object and you get a null exception. What's really probably happening somehow is that you're not filling your words properly, or thinking there are more words than there are, or something like that. And so maybe you have a few words in here, a, boy, the, but somehow you're grabbing this spot here and trying to do something to it, and it's going to throw a null exception. So the null exception will tell you what line it was thrown at. I would look carefully at that message and see where it is. It's probably some spot that has words at some index dot. In fact, my guess is that you said, hey, tell me where this word is in the words array, and it returned a -1. And you tried to apply that to words array and say, give me the value of words array -1. It doesn't exist. Well, that'd be an index out of bounds error probably, so I don't know exactly what's going on. But that's what's going on there. Anything else? All right. I know it's hard, but the sad thing is it's not that hard. For our binary search, all right, here's our array. I'll put commas in here. And we want to find items, we want to search for items in this array. So first of all, what's the important thing about this array for binary search? What's the important property that it has? It's sorted, ascending order in this case. You could do descending, but then you have to switch the logic of the search around to make it work for that. This is still an array, so these all have indices, 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have values and index. And let's say we want to search for some value like 18. When we first start, 18 could be anywhere in the array, right? That's the basic idea, that we're going to sort of start off not knowing anything in particular about the thing. And we want to interrogate the array and ask it about certain values. And like the number guessing game, we want to start in the middle of the array, right? So the way we find the middle here is that we're going to have a low index, and we're going to have a high index. And those numbers represent the portion of the array that we believe still may contain the answer, the thing that we're looking for. And at the beginning, of course, the entire array may contain the answer. And we want to find the middle of these. Now, we're not finding the middle value, because in order to find the middle value, we'd have to know sort of exactly the distribution of values in that array, and what's the low value, what's the high value, and where's the skew of the whole thing, and all that kind of stuff. We have to know everything about the array to find the middle value. Instead, we want to find the middle index, right? So there's a couple, this is of a choice. We're going to find the middle index, and I'm claiming it's going to be the low value, start here, and then move forward halfway, plus the length. What am I doing there? Length divided by 2. The length is the number of elements in the array. So it's the high value minus the low value. But in this case, what would high minus low give us? It would give us 8, right? And how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 elements. So we got to add a 1 Add a 1 to this. And in fact, if you rearrange this, the high value is the length minus 1 kind of thing. That's how you normally find the high index, right? The length array minus 1. So it all kind of makes sense, even though it's a little bit, you kind of have to stare at it and sort of recreate. I have to kind of recreate that every time by doing a little example in my head, like how many items are there? And high index is 8. That's not, they don't match up, right? So let's add 1 more to it and I'll make it all work out. So for this example, our middle value is 0 plus, this length is 9 divided by 2. 9 divided by 2 is 4.5, but they're both integers, and so we lose the fractional part. So 0 plus 4, the middle value is 4. So we're going to say this is mid. Okay, got it? You have these sort of two important numbers that track which part of it we're looking at, and then we have this other number that we derive from those two values, that we compute from those two values in the middle, right? What do we do next? This is binary search. What's our first step to kind of like working through, making some progress on this search? We compare it to the key. The key is 18. We say is 618. The answer is no. If we're looking for 18, we know this is sorted. Where must the 18 lie relative to that middle point? It's got to be higher than 6, right? So we are going to update. We want to throw out all that portion of the array. And again, we don't want to throw it out by doing some like Java array dot remove kind of thing where it's actually like removing it from the array, because that's going to take a lot of work to do. Instead, we're going to change our low value to be mid plus 1. Mid was 4, plus 1 is 5, low is 5. Now our effective array goes between 5 and 8, and we're going to look for it here. Then we redo this computation. The length of this is 8 minus the low, 5, plus 1, this is 3, plus 1 is 4. So the length is 4. And in fact, 1, 2, 3, 4, there's 4 items in that part of the array. The middle is low, which is 5, plus length divided by 2 is 7. So we're saying the middle here is 7. Now the problem is that's not really the middle, right? If this is the middle, then there's 1 on this side and 2 on this side. It's not balanced. How's that the middle? But you got to make some kind of choice somewhere. If I were to pick 18, then there would have been 1 on that side of it and 2 on that side of it. So this is just the way it kind of rounds around for this particular computation. We add now we're just like on the high rate. We just hit the cruise control and we're just going, right? Because it's all the same after this. We say is 22 18? No, it is not. Is 22 bigger or less than 18? It is bigger, which means that we're going to trash it and the stuff to the right of it. We now set high to mid minus 1. And again, mid was here. We know it's not 18. We don't want to use it. So we're going to move 1 past it to 6. Low stays 5. Our length is 6 minus 5 plus 1 equals 2. Our low is 5. Our length divided by 2 is 1. So our middle, oops, I just lost, okay, high equals 6. And it's saying that the middle is 6. That might seem a little strange that the middle is the same as the high number, but it's okay. There's only 2 numbers left, right? So it's got to be the same as something here. So the low is 5, high is 6, the middle is 6, and we ask, is that equal to the key? It is. And so we return that thing we just looked at, the index, the 6. Yeah.
Would the optimal loop for this be a while loop with a, you could create a Boolean variable called key found and set it to false, and while it's false it runs, but then once you find the key, you can change a key found to true and the loop?
So okay, so the question was how are we gonna know when to end? And that's actually the next step. In this case, if the values at the mid equals key, I'm just gonna say return mid. I don't have to set some Boolean. Now there is one trickier case. Let's say we were looking for 17. Okay? We would have progressed the same up to this point, except that now mid equals 6. Is 18 equal to 17? No, it's not. Which part? This is our remaining array. What do we do next? We're going to say that high equals the mid minus 1. High equals 5. Low is 5. Mid equals 5. This is our remaining array, right? We'll squish it down to one possibility. Let's see if I mean, you're all saying, that's not 17, but we still have to do the math and figure out where this middle point is, right? So the length is 5 minus 5 plus 1 equals 1. Low is 5 plus 1 divided by 2, which goes to 0, so it equals 5. So low is 5, high is 5, mid equals 5. We're all kind of the same here. Is 13 equal to 17?
No.
No? What happens next? Well, 13 is less than 17. So we want to throw away it and everything to its left. And we throw it away by changing the low value. Low becomes mid plus 1 equals 6. Low is 6, high is 5. That's sort of weird, right? We're saying the valid range goes from low to high, and all of a sudden low is bigger than the high. And that means we run out of options. There's no more places to look, and the item is not found. So there's two possibilities for finishing. One is the value at mid, we find it, and we return that index. The other one is we have like a while loop. And we loop while low is less than or equal to high. As soon as low becomes bigger than high, we stop and quit. Let's look at some code real quick. So last time, we got partway through this. We had our low, we had our high. This valid length is the length variable I'm computing here. High minus low plus 1. Middle equals low plus valid length divided by 2. And then we check the value at mid, and if it's equal to key, we return the mid. If the numbers is greater than the key, then that means that everything to the right of the key must be thrown away. And so we bring the high value back to throw it away. And if it's the other way, if it's smaller, then we're throwing away the left side of the array, and we scoot the low value up to get rid of that side of the array. So those are the three possibilities. And now we need to kind of loop over this thing. So we set up our initial low and high, and then we're going to say while low is less than or equal to high, do all that subdividing kind of stuff. And the indenting is bad. All right, so the basic algorithm is pretty easy. You set up some bounds on the array. You loop, you find the length of it, you find the middle point, you check the middle point, 3 possible cases, and either you're done or you change the low point to go up or the high point to come down, and then you just repeat. And if this is no longer true, if low escapes past high like it did here, then we know we've run out of things to look at, and we're going to return -1 to show that we did not find that value. Okay? If I were to run this, should work, I guess. So if we're looking for value 5, that's at index 0, 1, 2, 3, 4, and it found it, hooray. And if we look for 15, it doesn't find it and prints -1. Now, if you really want to know what's going on, each time through this here, you should probably print out high, low, and length and middle, and kind of draw it out on something like this and figure out, you know, what's actually going on. But if you work through by hand, you get the same answer. Now the problem is, once I get this answer, and I'm like, oh, what happened? I don't find it. Low gets bigger than high. I encode it here in my code. I've like satisfied myself that that's true. 5 minutes later, when I look at that, I forget why this is the thing we stop at. It doesn't make any sense to me anymore. So don't worry about that. If you like have to continually go back through, search for something that doesn't exist in the array, do all these high, low, mid, length computations over and over again, and eventually you'll get to this point where low is bigger than high, and you go like, oh, that's when I stop. But, you know, just looking at this code, that is not very informative to me as why that's the time you stop. Basically, it stops because those have crossed over. There's no values in between them anymore, right? That's the sort of intuition behind it. But I have to keep working on that thought process to know why that's true. So don't be sad if you have to keep working on that to know why that's true as well. It's not like an easy conclusion to come to in some sense. Okay, so we're going to be using this code. This is basically a fully implemented binary search code. You don't have to reinvent it yourself, right? But you should have some understanding of this process, like how this works. Like you should be able to do it by hand on a test, for example. Okay. All right, let me just talk briefly about one other little topic because I wanted to say something. Let me just skip this for a second. Oh, let me say one thing. So binary search throws away half the array each time. That's like, okay, it's a big deal, right? In practice, what that means is that if you're searching 4 billion names and it takes some number of steps, 20 steps, you can search 8 billion names with one more step, one more time through the loop, right? So I get 4 billion almost for free. It only takes me one more time through the loop to search double the number of names. So when you're going from 1 to 2, it's like, 2 to 4, no big deal. But if you're Google and you've got 4 billion things or 8 billion things, and it only costs you one more iteration of the loop instead of 4 billion more iterations of the loop like it would for sequential search, it's a very big deal, right? So these algorithms are very powerful for that kind of stuff. Well, I'm going to actually save this for a whole other topic. So I guess we're done. Yay! Work on your assignments. Take a little break.